Bruce, George, come on. Come on. They gotta make their own decisions to come. Good boy. Come on. Come on. There's Bruce. Come on, George. Thanks. Good boy, George. Bruce. Safety inspection. CAT scan. Bruce, George. 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 You want Bruce? I'll bring you guys out here to work. It's Saturday, and you guys don't want to work. What kind of union crap is this? Guys, want to see what I'm putting up with? It's a tailgate strike. They're tailgating. Yeah, whatever. They're tailgating. They could care less. It's a strike. Huh. It's a cat strike. Very interesting. You both can go. Be gone. I don't care. There you go. Inspect everything. Come on. Go. Bruce, go. No, I'm not going to pull you. This one's going to pull you. You guys are tied together. You know that, right? So, cow time. Cow time. Okay, so I set up a little model here. I want you to consider the slab, that part was part of the floor, inside. I want you to consider that to be one of the columns. Column detail to be not shown as such. So here's the columns I'm referring to. This might be near the top floor. Alright, so what do we have here? This is where our floor is connected. Our floor is connected there. Alright, that's our floor connection. We can see from this floor connection, reinforcements near the top right there. And this one appears to be flapping down. This might be conduit. It ran through there for some electricity or something like that. Looks like that's what it appears to me, roughly. So we do this. We zoom in on it. I see one piece of rebar there, reinforcement. This looks like just like I said, like a piece of conduit, piece of pipe. Doesn't look like reinforcement. It ran through the column. This could be wiring. This is where the columns, how they did the detail and where they married it up to the new floor and the concrete from here to here. All right, so I'm going to show, this is what I'm going to be focusing on showing you in the video, how the floor is connected to the column and how easy that makes it for failure. That looks like the end of the rebar, so it went through, interacted with the floor out to that distance. And you can see it fell right about to there before a new moment was created with the column going in a new direction and then popping it in that direction. It's as if the history, if you can reverse this, putting the concrete back over it, it would be at that format and then back up. So first you had that bend right about to there if you want to bend this concrete. Then the backside kicked out and it slipped away. This had some rebound effect to it. It's not quite springy, not at all, pretty much, but it has some rebound effect must have taken place. I mean, very, very small, because you can bend rebar and it stays where you put it. This is intriguing. This right here is very intriguing. What's noteworthy is there's no more pipes there. Noteworthy is the one floor, on the 8th floor, there's a piece of slab still there. And it's in one direction facing us. That's very noteworthy. I'm going to do a separate video on that one day when I get around to it. So now you see the column. You can see we're behind these firemen. There's the rest of the column. They're fractured, bent, broke. But you see no floors interacting with it. See how no floors connected to it? No floors. So this should be part of my video showing that no floor interactions. It all just pulled away from the columns. And let's go from there. Right here with the mouse. You can still find it. I show that in this content how the crane shows the columns were built as such. that they were already sticking up, ready for the next pour to go on top of it after they get to that floor level. This looks to be about the same level as the pool deck and the parking area appear to be the same deck in this video. But this shows you the column design, and this helps you understand that the columns were done, and then the floor. Recall that the columns required, they were going to be 6,000 psi, and then 5,000, and then 4,000. Here's an image from the documents: 6,000, 5,000, 4,000, and the floor locations. So what you're seeing is it went from 6, 5 to 4, but here it shows the floors will be 4,000 psi up to the 8th floor. From there, they're going to transition. They did transition supposedly to 3,000 psi for the remainder. So up to the 8th floor, you have interaction of 4,000 psi pads interacting with a stronger psi column, the load-bearing columns. So you do have some mixture, which proves that they had to pour them separately, the floors and the columns. So they're going to do 6,000, I think, up to the 8th floor. Then they're switching over to 5, and then ultimately 4,000 psi. But the floor was at a separate psi. So therefore, a lower psi than this lower floor here. So you can't pour the floor. You cannot pour the floor and the columns at the same time if you got two different psi's. They would just blend. So that shows you the columns were built first, and then the floors were added as they went. Columns, floor, columns, floor. And could that have made a weak connection? Well, you think it would have been more weak in the columns than the floor, because the columns would have been experiencing the load transfer of a breaking point at that point. But those images I have in the video do not indicate that. There's a bunch of them right there. I'm trying to freeze it. So right here is a bunch of images with no floor connected to them. They just all pulled away. Everywhere they just pulled away. Very easily disengaged. The flooring did. The columns, the reinforcements stayed together through the whole collapse, as you can see pretty much. Stay together like links on a sausage. Most of it stayed together at least two at a time. So you have the floors breaking away from the columns at least two at a time. Doom, 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 doom. You'll be able to repeat the amount of floors it broke by looking at these columns in here. They went through it like a wrecking ball will go through it. They really trashed a lot of data. But here's the data nevertheless. That how I'm explaining to you, the floors pulled away from the columns. The columns never buckled. I know there's a couple people saying the columns buckled and all. These columns at the top never buckled. They were stripped away. They were stripped down. They might have got fractured at the bottom, one or two of them, but that's, you know, it'll be an impact. But have that ledge, this other piece right here, is not. That would be another floor right here. This detail is not present. This secondary one. It's surface face mounted. Face mounted, if you will, with rebar holding it up. So I'll show you in a second what I mean by that. What I mean by that is that rebar going from here into here. This doesn't exist. This exists. In real life, this would exist. This is used 6,000 psi on the first, so many levels up. Then they changed to 5,000. Then they changed to 4,000. Nevertheless, these did not fail. What failed were the interaction between the deck and these. What caused the failure was that rattling effect when the ledger got pulled off at the base here, when the deck was separated. One second here. A little demo problem here. These little couple of rocks to help balance this thing. Okay, so let's go ahead and do this little. So now what I set up for you is basically the pool deck, The interior slabs at different elevation. This was higher, this was up there. They were not of the same elevation. So if I would add this one on top of there, you would see it a little, get an idea that they're not the same elevation. The point being is that they are interconnected. Oh boy, this is going to... Whew, that was a little bit of work. Let me remove the plastic. So that's just the plastic. I want to get you an idea. This is the pool deck. Let's call this the top surface. This is the floor inside the lobby area inside the living quarters on the first floor. Thereabouts, you know, just not to scale obviously, but I want you to be able to visualize that there was an elevation change. It was tied in with some linkage of concrete. And here's the elevation change per the structural drawings. This is how they did the elevation change. 12 inches go up, tied to the interior wall. So clearly they're interlocked, the deck and the interior floor. And rebar going this way and that way. So I said I would get you that rebar. I would add to the drawing about the rebar. So this will help you visualize it, sort of like that. Let's do that. So now that should help you visualize the rebar coming up into that deck, turned into this one also. So it was, but it's a simple version of it. Reality, they used links like this and then rebar this way and this way. But this is the simple version to help you understand what's going on. It comes over, comes down, comes over. Do not think this is exactly the rebar setup. We really don't know that, the true rebar setup, and we only know what we're going with. This would be one of the columns. It had many columns holding it up, holding up the floors. Let's look at that floor detail. So the floor detail, here's the pool deck. I'm on top of it. Here's a column. The floor attached to the columns, not by anything supporting it like that, but by steel. Went from the columns into the deck. They poured these columns first, then the decks second. We know that if you look at the this concrete schedule, it shows how 6,000, then it changed to 5,000, then to 4,000. So you can't pour the floor. The floors are, I think, are only supposed to be like a mixture of 4,000 and 3,000. That's it. That you can't have a 6,000 psi column if the floors were spec'd at the max. Let's say at the max at 4,500. So these two would automatically, by default, it would not be able to be poured together, the floor and the column. So they pour the columns first, leaving steel sticking out to be able to pour the concrete into there. That puts this, all the walls in shear like that. Now we get the pool deck that I'm standing on, puncturing, falling away. As it falls away, as it pulls away, it pulls on this column down here, right down here. I might have to back up and give you a little more view. I think that might work. So as this pulls away that I'm standing on, as it falls away, it's also reinforced. Remember, from here down to here into here. So it pulls on this floor here. As this floor collapses, it pulls on this floor. When it pulls on this floor, these columns are mounted on the top of it, all the way down to the piers, to the ground, as I understand it. And so when it pulls on it, on this flooring, it rattles this guy, right? There's your rattling. But look, here's the rebar inside here. I'm going to pull on it, and you'll see that it'll separate right here. So when it separates like that, you see, watch this fine dust. You see that fine dust go down. And floor number 7. Let's do that again. Let's zoom in on that one. So floor number 7, as the camera's there, you see, let me make sure you can see it. As it breaks away, you see those see the particles as it's breaking away. Video where you'll see the particles rain down. Initially they're raining down towards us. I mean straight down. But take note of that trajectory right there. That there shows the impact, and then right here, impact, and then towards us. Impact towards us. So the chips are actually coming on an angle, sort of like that, to be the impact and come towards us. Both of them are parallel, appears present, parallel and coming towards us. The ring camera, you could actually figure out how many frames per second it's doing, and you'd be able to figure out what we're actually looking at, how much time it actually took. Frames per second if you knew the ring camera, etc. This appears to just be sitting on some, these are just the furniture and the angle, the lens is throwing us off. This is not sitting on top of it. That's those square legs, and it looks like a couch. We'll see some torque action going on here, but of the one wall, roughly appears that way. But remember, this is a ring camera. They have a wide angle lens on them. Okay, here's the particles coming towards us, raining towards us in that angle. Now I can see the side of the wall, whereas I don't think I could see the side of the wall initially. Well, there's the side of the wall. There's the gap there. There's the initial surge of the breakaway. Remember, the connection is very minimum in the rebar reinforcement. So our columns are inside here. We don't need to go down that far trying to locate the columns in this room. What matters, I want to show you the content of the trajectory of this reinforcement being ripped out is what you're looking at. And the floor above. There's a sway there to the left. So this is 711. So to the left of 711, I believe this is 711, right? So to the left of 711, as we face the building, is where this floor is going towards at this point. All right. You see those particles come down into the video. Now those particles are actually coming in a trajectory, so it implies it started coming back here, because they're in a trajectory. If you looked at the video slow enough, and you'll see them bounce. So they're elastic. They hit and then they bounce off in an arch. So it tells you the direction, like a pool game. Think. Tells you the direction it came in. So it would have come in like that, in an angled trajectory like that. So our failure was back here, further back. So, and it bounced, and you see them projecting. You can slow down the video and watch it. Back to this. Let's get the zoom back out. Let me zoom back out for you. So back to this guy here. So these are all mounted with rebar into the columns. The columns did not fail. The columns were forced, when it came apart, it pulled out of here, out of the flooring, so much so that this floor then separated. Now I have this here for support of this, but you can put this on the top floor. As you can imagine, as I pull away from the rebar, the reinforcement from this one, it holds up about 7 minutes before ultimately falling. Let me look at the video. Before ultimately falling, collapsing down. So this will be the column. So I'm going to hold this. I'm going to get rid of this one because it doesn't exist. I'm going to put this back in there, back inside. Not as easy as it looks. So I'll bring this back over. So as the column pulls away, with the reinforcement, right? It pulls away, it falls down. Simply hitting the floor below it, it breaks the seal, the reinforcement there, and then one after another, it goes. As you can see, it pulled on that one over there, right? It pulled on the face. As it did that, nothing's for free, as I always say, right? There's another floor back here that's connected further back. It pulls on that floor. It then pulls this column. There's another column back there somewhere. It pulls on that column, and the collapse is such that we see in the video. But I want you to now have a better chance. I can do better than this. I just wanted to show you, get you going on what this looks like visualization-wise. How the columns did not fail, but rather the reinforcement between the columns in the floor is the failure mode. after it was yanked free from the deck mode, from the deck being linked up. So as I always said in the beginning, this is simply a deck ledger failure that started it. The deck started this failure. We see these laying down in good shape. We see them laying down, and I'll show you that in the video. And in this video, let me go edit it and let me get you some stuff, and we'll go from there, right? The boys. Sorry, Brucey and Georgie. Bruce, all right, George. Saturday afternoon. It's got some tough actors. Look at this. Oh well, they're not with it today. Whatever. Enjoy yourselves, dudes.